Hi, my name is Amanda Mason,
And I'm Nermeen Coker.
and we will be doing our project on the electrogastrogram. So this is a little table of contents of what we will be talking about. We'll start off with what the electrogastrogram is and what it's used for, and then I'll go in on the input and output variables. And then we will talk about the process of building our circuit and the different components of why we have it built this way. So what is the electrogastrogram? It is a non-invasive test that measures the electrical activity in the stomach before, during, and after food. The electrical activity of the stomach controls the timing and speed of gastric peristaltic contractions. So how is the electrogastrogram measured? So recordings will be relatively long given the low oscillation frequency of the stomach, so it will take a while. And so how it's set up is basically several electrodes are placed onto the abdomen over different parts of the stomach. It is not inside the body. And then so the electrodes sense the stomach muscles, electrical signals, and the signals are recorded and displayed on a computer. The signals are displayed as waveforms, which can be analyzed. The stomach positions vary for each patient, so the need for the different amounts of electrodes covering the left abdomen can vary. So for the input and output variables, our input variable of our circuit will be the electrical signals picked up by the electrodes attached to the outside of the stomach. These voltages will be filtered and summed together by a series of different op amps and values. So, and then for our output variable of our circuit will be the summation of the filtered voltages and outputted into a waveform in the sine wave. The final signal will be displayed on a computer screen. So now we will go into how our circuit is built.
So using all of this information, we developed a circuit diagram. Since we have 6 to 8 sensors that get placed on the stomach, they all have to get inputted in separately. They then all follow the same voltage follower, op amp, and band pass filter before getting summed up and outputted. To make this a little easier to follow, we isolated one single pathway to break down the components of the circuit and to make the design of the circuit a little easier to see. This is that right there. So the first part of the circuit is the input and voltage follower op amp. The sensors are placed on the stomach and input a voltage through the circuit, which then goes through an inverting voltage follower op amp. This inverting voltage follower op amp has a very high internal resistor, which keeps the signal from having a potential backwards flow. This prevents any signal from backtracking and harming the patient. Since this op amp is inverting, however, the signal must be inverted again to keep the signal in its correct form, and this is seen later on in the circuit. Next, the signal will then go through a bandpass filter, which only allows frequencies within a certain bandpass to pass through. It works by combining a high pass and low pass filter. In this specific circuit, we also introduce an amplification stage. Since the frequencies are small values, the stomach signals are between 0.0083 hertz and 0.15 hertz, so we also computed a gain of 100. In order to do this, we had to use some equations. For the leftmost and rightmost resistors and capacitor values, the equation 1 over 2 pi RC was used and set equal to 0.0083 and 0.15 respectively. The left side is a high-pass filter, so the resistor was set at a constant 1 ohm, and then the capacitor value was found to be 1.06 farads. The same process was used for the right side, and the capacitor was found to be 19.17 farads. In order to calculate the resistor values used in the middle of the circuit, we use the equation gain is equal to 1 plus the resistor over the other resistor, and doing this, we just found ratios of resistors that worked for a gain of 100, since that is what we knew we wanted. The last part of the circuit that the signal goes through is the inverting summation op amp. Here the signal is corrected by being inverted again, and all 6 to 8 inputs combine to create one output voltage. This is then displayed on a computer for the doctor to read. That's the end of our presentation. Here are our sources. Thank you.